All right, viewers, welcome back to my YouTube channel. Hope by the grace of God you are doing well. Well, in today's video, we have a question on the board about a circuit whereby this particular circuit is not mentioned, but a power is given, voltage, that is a supply, is given, and then the power factor is given. And the question is asking us we should calculate for the current. I want to read the question and then we'll see how possible best we can carry out this calculation. All right, the question says a circuit takes 542 watts from a supply at 230 volts at a power factor of 0.63. Calculate the current flowing. Well, in this case, I'll put the data there. Some may like to write it maybe in a formula form by bringing those voltage, the watts in a data form. Some may also like to put it in a data form in the form of diagram. I'll put all those data there. So the question says the circuit takes 542 watts. So power, that for 542 watts is the power, and then from a supply at 230 volts. So the supply is the voltage, the total voltage or the supply voltage. We can make it VT or VS, which is 230 volts. And the question also has within it a power factor at a power factor of 0.63. So we have the power factor of 0.63. All right, so the question is asking us to calculate the current flowing. So the current flowing is unknown. We put a question mark here. Let me put another data form in the form of diagram. So this is another data in the form of diagram. So let's say we have, let's put our light symbol. This is our light symbol. The question is saying this particular circuit has a voltage of plus minus, has a voltage, total voltage of what? 230 volts. 230 volts at a power. So we know the current flowing. The current flowing in this case is unknown. We have to find the current that is flowing in this circuit. Remember, this circuit is a cross path. If you look at it, it's a cross path question. And the question is telling us there is a power that we know power current times voltage. This current times voltage times the power factor will give us the power. So the power, which is power, is equal to current times voltage, is given as 542 watts, and we know the power factor as 0.63. Right, so let's check for how we can be able to calculate for the current. So solution, we have to bring the formula of finding power. So power equal to current times voltage times power factor, which can also write it as current times voltage times cos. All right, so in this case, let's put the values. We know the power as what? Power here as 542. We don't know current, so we bring the I. We know the voltage as 230, so we bring 230. And then we know power factor as 0.63. So 0.63. So here, when you get here, I would like us to bring the formula again. Then we are able to find what? Break it down, manipulate it, and get the current formula from this particular power formula. So power equal to current times voltage times power factor. Watch very carefully. When you look behind this equal sign, power is standing alone, P, and when you look Beyond the equal sign, we have current times voltage times power factor, which they are three. How do we break it down so that we can get the current as the formula? What you do is that we can see voltage and power factor multiplying current, and we have to go away voltage and power factor. So what do? We divide both sides by what? Voltage times power factor. Divide both sides by voltage times power factor. Then what do? We cancel. Voltage cancel voltage. You see, we are getting away voltage and power factor. Power factor cancel power factor. At the end, current stand alone. So current equal to power over voltage times power over voltage times power factor. So current is equal to power divided by voltage times power factor. Now let's bring the formula here. Power current is equal to power divided by voltage times power factor. So let's bring this back, this particular back. 542 current, because that is where we got before we use the formula, and we are able to get the formula I. All right, so current times 230 times the power factor 63. So here we know this stands for the power, equal to, this is I, this stands for the voltage, and then this stands for the power factor. So as you can see, that is what we did here. We took the numbers or the values and we replaced them with this kind of items. So what we do here, we write this formula back, which is current equal to power over voltage times power factor, which is equal to, power is what? 542 watts. So 542 divided by voltage times power factor. The voltage is 230 volts. So 230 volts times power factor is 0.63. So 0.63. So current is equal to 542 divided by, let's use our calculator. Use your calculator and check. 230 times 0.63. 230 times 0.663 will give us 144.9. So we have 144.9. So our current will be, let's see, 542 divided by 144.9. Let's divide it and see. 542 divided by 144.9 will give us 3.74 amps. The value is long. When you write that long value, you multiply, you get the same answer. You get the same answer. So now we have the current as, so the current here now, the current flowing now is what? 3.74 amps. All right, when you get here, the question did not ask you to prove, but you can prove by bringing this current. You see now, power is equal to current times voltage by power factor. Now we have the current, that is what we have here. We have the voltage as 230. We have the power factor as 0.63. I want us to multiply this current by the voltage by the power factor and see whether we'll get power. Then that tells us our answer is correct. So we are doing it here to see. So power equal to current times voltage times power factor. So power equal to current 3.74 times voltage is 230, power factor times 0.63. Let's do it and see whether the question, or we will get 542 watts. So 3.74 times 230 times 0.63, we have 541. So this is what we have, 541 541.926 watts. When you compare, you see that approximately 541.926 approximately is 542. But when you come here, 542 divided by 144.9, you get a long number. When you use that long number and you multiply by the current by the power factor, you see that you get exactly 542. You can try your hands on that and you see that at the end you will get that answer. But when you write it in a uniform form like this, in a very small form like this, you break it down. Definitely, maybe sometimes you will not get actual 542, but once you get 541, look at it, we have 542, 541.926. So approximately we have 542. So this can be also expressed approximately 542 watt. So this is the answer for when the question is given to you in this form. In the next video, I'll show you how to calculate for power when the voltage is given, when the power factor is given, and when the current is given. Right. Viewers, comment below. If you have an idea, or maybe you have seen something, or you want me to improve upon something, you can put it on the comment below. Well, we are in the world as one unit to solve problem, and therefore we have to be one, so that whatever, maybe in the case I've done any mistake somewhere, you can drop a comment, or you want me to improve, you can drop a comment. Right, so comment below, subscribe on my videos, share my videos, and like my videos. As usual, as I used to say, sow your today and reap your tomorrow. Bye for now.